among Africans who are in diaspora. And before I go ahead, I'm just going to say that this meeting is being recorded, and you would have gotten a prompt just then as the recording started. Please note that it's for the purposes of the network, and if you don't want your video to appear, please just close your video. I hope that will be fine with you. So thank you very much for that. And it's so that's what the ARN network is, African Research Network, and it includes PhD researchers or other early career scholars from various universities in Europe, in America, in Canada, and many African nations. And you can find that on our website. So what are the objectives that we have? Just as I've been stating, the main objectives are to enhance collaboration and networking, to share information on job opportunities and life generally in the UK. This is supposed to be a hub very much for helping and lifting one another, and to express and to give a platform for people's for expression of views, expression of intellectual property, expression also of thinking, and to find a place where you can express things that perhaps elsewhere you wouldn't be able to. You wouldn't have the opportunity to do that, or have the support that you need to do that. So that's the vision. That's the objective of the network, is to discuss publications and ongoing research to improve our visibility and to improve presence and our relevance, in our current climate. And so some of the activities that we do are to organize monthly webinars that focus on topics that are very crucial, essential to our daily lives and to our realities, right? And those topics, if you've been following the webinars that we've had since the middle of last year up until this point, there've been things that have hit at the heart of various different points in different disciplines. And I would enjoy you to go on the YouTube channel, and you'll find a record of all these things and the speakers that we've had and the things that they've been here to discuss with us, and very lively discussions that our participants, you people that are participating in today, have had to share and had to say and had to submit during these webinars, and even sometimes after the webinar. And we organize yearly conferences on issues related to methodologies, approaches to doing research on Africa, and all those kinds of things. And so that is a breakdown of what the objectives and the activities are. And we enjoin you to register to be a part of what we're doing, so that we can we and members of the network can benefit from your resource or from your expertise, and you can also have a thing or two to benefit from the people. So these are the network, the webinars that we've had in the past. You see, in November we had one concerning laws, UK laws, policing and immigrants in the country, policing and immigrant in context. We had one in October, positionality and intersectionality, situating African agency in humanistic studies. And you see the other one that we had there in September. And the thing to notice about them is the interdisciplinary nature of them, is that they don't focus on just one discipline, but they bring together experts and learned researchers from different fields to come and say things that are about specific topics, to enlighten our members and to also provoke thoughts and to bring lively discussions that could either produce solutions or produce another line of research which people can explore. And as part of the network's duties, we also have newsletters that we produce every month, and we have them in different versions. We have them in English, in French, and even also in Russian. And this is usually cascaded to members of the network. And so if you become a member as well, you would be able to have access to all of that. I'm going to skim through all the discussions, which these are just the ones that we've had up until today. And today's event is this: our knowledge of the universe, the African perspective. And we have
Dr. Anthony Ezeribe, who is a scholar in the University of Sheffield. And Dr. Ezeribe has done extensive work on new particles and rare particle events, sensitive detectors in the quietest part of the Earth. His current work focuses on development of liquid argon TCP. I can assure you I am not in the sciences, so I might not be familiar with some of these terms, but he's also, he's a physicist and electronic design expert who is working on the construction team for SBND and proposed DUNE detectors. I'm sure in the course of your presentation, you might shed light on some of these events. And yeah, so data from this research will be used in sterile neutrino physics, and this it would further increase our knowledge of how physics can be related to African studies in general. So our second presenter for today would be Dr. Emmanuel Dansu, and Dr. Emmanuel is also a research scholar who is working in African related mathematical studies. He got his he got his PhD recently from the University of Tohoku in Sendai, Japan, and congratulations again, Dr. Dansu, for this feat. And then, yes, his research is focused on mathematical modeling of population dynamics in biological and social systems using systems of differential equations. And he seeks to apply these ideas to solving problems relating to healthcare and the environment, especially with an African focus. So this is like a very brief, tidbit about our presenters today. And the formats that our presentations would take would be, we would have firstly 15 minutes conversations or presentations rather by our discussants. And we would also have in between this brief conversation, this 15 minutes presentations, we'll have a 5 minutes recap of trying to tie together the ideas that they have presented. So the first presenter would have 15 minutes, we'll have 5 minutes in between, and then the second presenter would also have 15 minutes, and then we're going to have approximately 20 minutes questions and answers. So in the course of the presentation, if you have questions related to physics, understanding mathematics as it relates to African studies in general, please feel free to type them into the chat, and then we will pass those on to the presenters as they progress. So welcome everyone, thank you very much. And I think we would start with Dr. Anthony Ezeribe, and you have the floor for 15 minutes, sir. You might need to unmute yourself.
Okay, thanks. Yes, for some reason I couldn't unmute myself. Thanks everyone. My name is Anthony. I will go straight to my talk. If anyone has question at any point, please don't hesitate to stop me. I will share my slides. Hopefully you can see this.
Yes.
Right. So I'm not a historian. I'm a physicist. So what I will do is to tell you about everything we know about the universe and try to drive home the point that there has been studies in Africa even before what we know today as the contemporary science started. Okay. So what I'm going to talk to you about is our summary of our knowledge of the universe. This is going to touch the Big Bang Theory. I'm going to talk about what that is. Then the content of the universe, what is the universe made of? Then I will touch my research efforts, and then the quest for knowledge in ancient Africa and the setbacks we've had in Africa. Evolution of the universe. So what we think now that gave birth to what we know as the universe is that there was a dense point, a dense point in time that had a lot of energy that created a bang. We call this bang a big bang, okay? Through time, so if you take this axis as the time, and this is space, or size if you like. Through time, the Big Bang, the light from the Big Bang cooled to the present day. The present day is in red here. So there has been inflation. This early stage was dominated by radiation, by light, if you like. Okay, so initially we had things like hydrogen, very light element, okay, combining to form heavier elements like helium and so on, to the current, maybe lead and so on. As that goes on, a couple of million years later, we had like formation of stars, galaxies, and so on. That chain continued until the present day that you and me are seeing. There are theories about what's going to happen beyond, but I don't want to dwell on that. But if you look at this picture, what the picture is saying is there's going to be some annihilation. That is, say, in 10 to 100 billion years to come, matter will be trapped in black holes, you know, due to proton decays, the black holes will evaporate. And then you're going to find an empty universe that is going to annihilate back to the initial point where we started. So this is what we think. It is a theory. The only thing we know is today and possibly our observable universe. So our observable universe is the time we can look back to. So from this present day, we can look back to this point. Anything beyond this point, we don't quite know. So we know what is happening today. We know what happened up to somewhere around this point. But very close to the Big Bang, we don't know what happened. So we can only try to extrapolate what we think that actually went on. That's our understanding. Because I said that the current today is matter dominated the universe. So we started with a radiation dominated universe, and now we are in matter dominated universe. I'm going to tell you what matter is. I know some of you, if you offer the science course, they will tell you that matter is anything that has mass and occupies space. And they are made up of atoms. Their constituents are atoms. Okay, if you take an atom, at the center of the atom is a nucleus. The nucleus has some protons and neutrons, the red bit and the ash bit. They made up the nucleus. Then on the shell is the electron, which is negatively charged. It moves round the shell. I put in this table just to give you an idea of what's going on. If you look at the charge, the neutron has no charge, but the proton has some charge. The mass of proton and neutron are about the same. The relative mass, yes, they are the same. In terms of electron, the electron is small, far smaller than the proton. So yes, in summary, the center of atom is a nucleus. Yes, we've said all that. The only thing I want you to pick from here is that the electron is, you know, about 1,800 times lighter than the proton. So electrons are regarded as elementary particles because they cannot be broken into some other things. Okay, so if you look at this video, what we are doing to study the proton. So at CERN in Switzerland, they strip off protons from helium and accelerate that into very high energy. Okay, so these rings are like boosters. They add energy to the proton. Okay, so on detectors, they collide these protons. So we're going to see the collision as you get to the Atlas experiment. It's going to collide and form subatomic particles. Those subatomic particles is what we study to understand the fragment components of a proton. So this is one of the detectors. If the protons collide, a shower of particles are produced. Okay, so we look at this event and then study each of the particle that is created in that interaction. Okay, so study what was got from one of those events is this. So we now know that protons and neutrons are made up of some things called quarks. Okay, so protons are made up of 2 up quarks and 1 down quark. Why neutrons are made up of 2 down quarks and 1 up quark. Okay, quarks are just our fundamental particles. They have half integral spin. The spin is, if you like, an angular momentum, a kind of angular momentum that obeys some form of, some certain statistics. We call them Fermi-Dirac statistics. Okay, and that statistics is nothing but, a description of particles over some energy states. Okay, for some systems consisting identical particles that obey a Pauli exclusion principle. The Pauli exclusion principle is saying that no two particles in the same atom could have the same set of quantum numbers. But don't worry about those details. The takeaway from here is protons are made up of some things called quarks. Okay, and we've broken protons to see these things. So from this, we know some other things that make up matter, that make up atom, if you like. All known elementary particles are summarized in this table. So the up that we saw in the proton, the up down, the second generation is, in terms of quarks, are called charm and strange. The third generation is top and bottom. And then gauge bosons. Gauge bosons are mediators. What these mediators are, they are interaction mediators. In human beings, when we want to interact, we speak to each other, okay? But for forces or for field, if you like, when they want to interact, they exchange these gauge bosons. So if something that has mass is interacting with another thing that has mass, let's take, for instance, the sun interacts with the moon, because the moon, okay, let's say the moon moves around, revolves around our planet, the Earth, so that they are interacting. Because they have mass, they are exchanging gluon. They are exchanging some gauge photons. Okay. If that interaction is gravitational, then they exchange graviton. If that interaction is strong, they exchange gluon. If it is electromagnetic, they exchange photons. If it is weak, they exchange either Z or W. And another class of particles that exist are called leptons. The most common lepton you will know is electrons, right? Electron that we saw in the atom. There are neutrinos that have flavors of electron. There are neutrinos that have flavors of muons, and there are other neutrinos that have flavors of taus. So muon and taus are just like electrons, but they have different characteristics in terms of mass. If you look at their mass, you see that they are heavier than electron. The most recent, discovered particle is the Higgs boson. Is a scalar boson that gives mass, gives field to other particles. On the right is basically all the particles that exist and when they were, well, maybe not all, but mainly all that I have shown here that exist and when they were discovered. Atom, as we know, it was discovered around 1803, and if you look, electron follows suit 94 years later in 1897, and then discovery continued until 2012. Okay, so since after 2012, we have not discovered any new particle. So, and it's been 9 years since after that discovery. If you look at the distribution of the time before discovery, you see that we are due for discovery. I think the outliers are 94, 21, 19, and 13. So So we should be expecting a new thing if there are more things that are unknown anytime anytime from now. So because we've talked about neutrinos, I will try to show you what is being done about them. So basically, neutrinos are neutral particles. They interact weakly, so they exchange Z bosons. There are billions of neutrinos passing through your palm, just your palm, every minute. Billions of them. But because they just pass through without interacting, you don't feel anything. They are probably the most abundant particle in the whole universe, but we don't understand everything about them. So it's really important that we study them to understand what they could help us to achieve. So this is a video of an upcoming experiment called Dune.
This is Fermilab, a Department of Energy national laboratory near Chicago. It's the starting place for the Deep Underground Neutrino Experiment, DUNE, powered by the Long Baseline Neutrino Facility, LBNF. The experiment begins with Fermilab's accelerator complex, which moves protons close to the speed of light. It's all part of an effort by more than 1,000 scientists from around the world to figure out how tiny particles called neutrinos work and what role they play in the evolution of our universe. Neutrinos are the most abundant matter particles in the cosmos, but very hard to catch. Trillions stream through you every second without leaving a trace. At LBNF, the beam of protons will smash into a target, creating the most intense beam of neutrinos in the world. Scientists will collect data to measure properties of neutrinos close to the source and again far away. Neutrinos change as they travel, so scientists are sending them straight through 1,300 kilometers of rock toward the DUNE detectors at the Sanford Underground Research Facility in South Dakota. The detectors can also look for the birth of neutron stars and black holes by catching neutrinos from exploding stars. The 1.5 kilometer deep detectors will be filled with 70,000 tons of liquid argon, making them the largest neutrino detectors in the world. As neutrinos interact with the cold liquid, they create a shower of other particles and light. Those particle tracks are then picked up by electronics and transmitted as data to the surface. The information will be analyzed by scientists at collaborating institutions in countries around the world. They'll use this data to solve unanswered questions about neutrinos, and maybe even figure out why matter exists. Things like planets, stars, and even you.
Right. Okay. So DUNE is an upcoming experiment, is under construction now to understand how neutrinos interact better.
Sorry to interrupt, Dr. Ezeribe.
Yes.
I think you have like 3 minutes or thereabouts to round off.
Okay. I will try to do
you.
that, but that would be difficult, but I will try. Okay, so
I'll say 3 to 4 minutes. That's fine.
Okay, so fundamental interactions. What are the type of forces that exist in the universe? There are basically 4. I think the most common one here is gravitational force. When you have an apple, gravity acts on it. So when the string gets weak, it falls down and drop on the floor. It's gravity. It's caused by curvature or space-time. Another common one is electromagnetic force. This you can see from light shining from the sun or from your torchlight. But the quantum scale ones are the strong and the weak, which you find in the nucleus of atoms. Let me now go into the theories and so on. So in summary, atoms make, which we understand, make only 4.6% of the universe. There are some things called dark matter. They make up 24%. And then dark energy makes up 71% of energy density of the universe. So what this is telling us is all we know about the universe, all the professors that have ever been in the universe, have studied only 4.6% of everything. Okay. So that is telling us that there's a whole lot of things to study. My work, I've worked in research for dark matter using the drift. This is me putting together one of the chart readouts for drift. This is a side of the drift detector. This is the drift detector shielded in the Bobby underground lab. Is 1.1 kilometer above below the surface. So it's an underground lab. This is one of the prototype readouts in Sheffield. These guys are from Elisabetta is from Italy, Sven is from US. These are our visitors from Japan. This is me, this is the director of the lab. In one of the videos that we just watched, we talked about Dune. So this is a prototype detector for Dune. All this is a detector. We call it a prototype because it's just like 1/10 of what the actual Dune will look like. But if you look at it, it's actually massive. It's currently in Switzerland, in CERN. This is the data coming out from the prototype. We have a beam of neutrinos coming from that angle, going into the detector. It's filled with liquid argon. And this is me in the lab. I actually took these pictures myself while on shift. These are the actual data coming from the detector. I'm also working on SPND. SPND is a short baseline neutrino experiment in Fermilab in US. And I have activities, cosmogenic measurements for the cosine experiment in South Korea. So science in Africa prior to discovery of atom in 1803. If you look on the right, Africans play a game with beads where they count 4 beads. Okay, they start with maybe 4 and then go through all the pots and come back. If the beat complete 4, then the guy wins for that pot. So what he's telling you is that there has been a counting system in Africa. Okay, it did not start with maybe colonization or anything. There has been a counting system in Africa, dating back as far back as 700 BC. On the left is the cowrie, which was which was used as a coin in ancient Africa. So people could buy oil, could buy food with cowries. So people were able to count cowries. They know values of cowries. So this is a proof of arithmetic in ancient Africa. There has been evidence of measurements. For instance, the lunar calendar in Egypt of 20,000 BC. There are other ways of measuring times in ancient Africa. They were able to measure seasons. They know when to cultivate their crops and when to harvest. So they understood the seasons. They were able to measure frequencies. So they were able to, for instance, following moon cycles. You know, in some places they took that as a month. They were able to have their own weeks. In some areas, it was, market days, 4 market days. In some parts of Nigeria is a week. They were able to measure directions. Okay, star direction. They were able to follow stars as it starts from a position and comes back to that position. They were able to measure distances. For instance, using foot length. They were able to measure wealth, by counting coins and counting number of children and so on. So this tells you that there was evidence of serious arithmetic, serious astronomy, serious cosmology in ancient Africa. And that is accompanied by different beliefs of the origin of the universe. They had different theories. If you like, you can call them mythology, but they were beliefs. Like in Ife, they have a certain belief of how the universe was created. In Congo DRC, in DRC, there is similar belief of how the universe was created. They understand this and they believed in it. But again, there has been a setback. Slave trade basically destroyed all the initial work of ancient Africans. Anything that was remaining from that was destroyed by colonization. Then our government policies don't make deliberate attempts to solve scientific problems. So these are major setbacks for science in Africa. In summary, I believe I've been able to tell you that there are a lot of progress have been made in understanding the universe. But though there are still a lot more that are not understood or even known, Africans are making major contributions in different areas of science to unravel these mysteries. Ancient Africans had basic understanding of arithmetic, which they applied in explaining the universe around us. And much work is needed to reposition science across the African continent. Thanks.
Thank you very much, Dr. Ezeribe. This has been very fantastic presentation that has drawn our attention to lots of items that I'm sure there will be questions.
In fact, I'm really grateful to Dr. Ezeribe. He has helped me with what I'm going to share today. So he has already set the ground for that for some things that we're talking about. Thank you so much for the opportunity, Dr. To ARN and Dr. Ezeribe. Thank you for that wonderful talk. So I think I want to go straight because the introduction has been done already, and anything you missed, you can see on this first slide, and in 2 seconds, we should be on the next one. Yeah, before I forget, my special friend is here, Fado Unom, is in Newcastle. I was so surprised to find him as one of the participants. Thank you for coming. Okay, I think I should call you Doctor, like, for seeing. All right. So we're talking about the knowledge of the universe, the African perspective. I'm a mathematician, but I'm very interested in the humanities. Now, I may be sounding like a historian today, but please don't be deceived. I'm not a historian, and I may not be doing it the proper way it is done in humanities, but I've just tried. So just like we know, every people group has their own unique experience as relating to the universe. So, everybody in their own space, they have things they experience, they have how they relate with the element around them and all of that. So, but, for the most part, just like Dr. Ezeribe already said, we know the usual culprits and all that because of certain things in our history. We now seemingly see the universe from the perspective of other people, maybe from the perspective of the Europeans or the Arabs or the Asians. But that is not to mean that there are no African perspectives to all of these things. In fact, all of these things. So, and that is one reason why I really appreciate what ARN is doing is that we are reminding ourselves that there's actually an African approach to everything, to science, to music, to everything, and it's probably some kind of renaissance. And I think it's very important that all hands are on deck in this case. So now, just like the Senegalese polymath, he did a whole lot of things. Cheikh Anta Diop and the British Martin Bernal, they gave us evidences that implies that Western civilization has African roots. Of course, it is agreed that Africa is the source, is the root of all humanity. So it is natural to expect that some civilizations, whatever people lay claim today, actually they have African origins. So just like Cheikh Anta Diop also suggested in his many write-ups, he said that if you're going to rediscover Africa after all the slave trade, be the Arab slave trade, the transatlantic slave trade, and colonization, and even the bad governance we have in many parts of Africa, we have to probably revisit the ancient Egyptian civilization. So it will be a core basis. Then he also has this thing about languages, that we have to revisit the languages and look back at what happened in ancient Egypt, which happened to be the source of most of what we call the civilization in the world today. Although some people would not want to agree with that, because they see people like Sheikh and Diop and Martin Bernal as controversial researchers. Um, so that takes us to the next slide, where I want to examine the ancient Egyptian civilization. Now, some of the features of that civilization includes the River Nile. The River Nile is such a very important part. Um, Wherever there's a water source, you can be sure a lot of economic activities go on around that place. You have a lot of agriculture. You have people settling around those places and everything. Then they were also well-established mathematical, architectural, and medical systems, in that ancient Egyptian civilization. Interestingly, two of the seven ancient wonders of the world were found in that ancient Egyptian civilization. Including the pyramids of Giza, which is still standing today. Like a lot of a big portion of it still stands today. Though the other one, the Lighthouse of Alexandria, got I think it was affected by an earthquake or something like that. And then, interestingly, the rulers of Egypt were not just men; they were also women, like Hatshepsut, Nefertiti, and Cleopatra. The next point talks about the fact that civilization was so cosmopolitan. You had people from all over the place, because it was such a thriving civilization that you had everybody. You had pharaohs that were, like when you talk about the Egyptian civilization, you're talking about Egypt itself, the ancient Egypt, and then you're talking about Kush, which is, I think it's a part of Ethiopia today. You talk about the Nubia, that's some part of Sudan and some part of Egypt today, and things were really happening. And and many researchers, there have been a lot of funny researches suggesting that the black man is less in intelligence compared to other people. But this civilization actually is a very good sign for us that that kind of stand is very far from the truth. Interestingly, quite a number of Greco-Roman philosophers were greatly influenced by the ancient Egyptian philosophy. Now, the first, if you check some sources, you discover that the person that most people recognize as the first philosopher, like as we know philosophy today, people like to start the idea of philosophy from Greece, but not forget, they do not tend to remember that most of these guys actually studied in Egypt. So in the next slide, we see Thales of Miletus, who was a pre-Socratic scholar. Before, we know a lot about Socrates, Plato, and Aristotle in that order. Being one, Socrates was the teacher of Plato. Plato taught Aristotle and everything. But there were people who were before Socrates, and they were philosophers. So he was the first person to whom a mathematical discovery was attributed. He was the first philosopher of the Greek tradition, and one of the seven sages of Greece. I think probably the most popular of them all, and all that. So interestingly, he was taught by Egyptian priests and was strongly influenced by ancient Egyptian mathematics and religion. I think many people want to see him as the first mathematician or philosopher and all that. And he used geometry to calculate the height of the pyramids and the distance of ships from the shore. Absolutely, the pyramids were in Egypt, and you even had, in fact, according to Emmanuel Kulu, who wrote "I Black Pharaoh, I Rise to Power," he actually believes that there were even more pyramids in places like Sudan and maybe Ethiopia and some other parts or something like that. So so for this person who is recognized as the first philosopher to be doing this, then it means Egypt has a plays a very crucial role in his philosophy. So Thales taught Anaximander. Anaximander was in turn the teacher of Pythagoras. And in mathematics, Pythagoras is a very popular person. In fact, the Pythagoras theorem is one of the most important discoveries in the history of mathematics. So we look at Pythagoras in the next slide. Pythagoras also had his own experience, his training in Egypt. So he founded Pythagoreanism, and the term mathema, which later became mathematics and means subject of instruction, was coined by people who followed Pythagoras. And there are sources that believe that things like that, like yeah, he must have actually learned that from Egypt or even parts of sub-Saharan Africa. Some of those things came from some parts of sub-Saharan Africa. If you look at the works of Paulus Gerdes, then Thales advised Pythagoras to study mathematics and philosophy in Egypt, because that was a place where it was all happening then. So because of that, Pythagoras left Samos, where he was born, for Egypt in 535 BC to study with temple priests. They were like the teachers of religion, philosophy, mathematics, architecture, and all of those things. So, and Pythagoras influenced Western philosophy through Plato and Aristotle. Plato and Aristotle, they have a very strong bearing on Western civilization, and they learned from Pythagoras, who learned from Egypt and other teachers like Thales and Anaximander. Then I'm afraid there may be a bit of interruption. If that happens, you'll give me a minute to reconnect with theorem is one of the most important mathematical discoveries, just like I said earlier. So I think at this point, I just let me take a break and continue from the next slide when or maybe most of us African have been washed to believe that probably if something is not coming from the white man, then it is not it. But the fact remains that, like we have seen already, we already see that some of the big boys in Greece actually cut their teeth in a place like Egypt. So the question again is the African worldview scientific? Let me try to switch now. As I was saying, I was talking about the question, is the African worldview scientific? And that's a question, and that's why I really appreciate what Dr. Ezeribe already did to show us that before colonization, before the slave trade, people had their own experiences, and we have always had our own counting systems in our different cultures. I remember in my culture, I think we count in 20s, and in mathematics, we have this thing called, different bases in which we'll count base 1, base 2, base 3, base 2. So you can call that base 20, right? So we've always had that, like it was anybody. So we also have our own, people had their way of observing time using the Earth's rotation. I still remember my grandmother looking at how the shadow is moving and being able to predict that this is happening now and all that. Then cock crows, can you imagine? Because from cock crow, somebody can know, it is 5 a.m., it is 4 a.m., and all of that. Or there are times a cock crows at an odd time, and that is a sign for something. And if you're talking about if the African worldview is scientific, I know one of the key elements of science is observation. So people have been able to observe their own environment, and they've been able to make decisions based on what they have observed. So like that. So we have our games, like the game Dr. Ezeribe showed, the Mancala. Interestingly, okay, yes, I think I had experience playing Mancala. It has variants all over the world. You have it in Asia. The time this came very strongly to me was when I was in Japan. There was this time went for an event, and one of the games on display was Mancala. Interestingly, different people, they have come up with their own different rules of playing the game, but it's still a variant of the same, what the Yorubas called Ayo. And I think it is called Awale in some other cultures and everything. It's still the same game, and that is highly mathematical. From there, you can see counting systems, you can see numbering, you can see algorithms. That there are things to do to win the game, right? So I see some computation in that even, and that was something that came out of Africa. So our knowledge of geometry and fractals, just look at our textile, look at the way our settlements are organized. Look at even the ancient times. I remember talking about the Dahomey Empire. There's this, even in Akure here, if you go to Idonre Hills, for instance, there's this ancient courtyard. You have this something like a round, you have a round, should I call that round table? You have a kind of quadrangle, and people are seated around in the quadrangles, and then you have the king, seated in a vantage position, legislating matters and, judging issues and things like that. So, we see a whole lot of geometry in our artwork, in our pottery, in our textile, even in the way we organize our communities. So, the question is the African worldview scientific? And the next slide, I think I have an answer to that. Because as far as you're a human being, you have an experience with your environment. You have you relate with things around you, and I think it is not a bad idea to say no culture has the monopoly of the knowledge of the universe, and the African worldview is as scientific as it gets. Fine. Maybe the other question is, if the African worldview is so scientific, why does it look like we are not as scientific as we should be? Of course, the usual culprits, but the fact remains that we cannot remain stuck in the past. We have to keep moving, and that is why an organization like RAN is coming to the rescue. And that's why I did not hesitate to buy into the idea, because we have to rediscover ourselves. Because today we import solutions to our problems, and most of the times they are counterproductive, because they did not really, the solutions are not designed. For instance, each time I drive my car, and I'm like, I just look at it like, no, this car is not meant for this place. We should have our own cars, right? You get a car and then it is changed from right hand to left and all of those things. So we have to brace up, we have to wake up and face it. At this point, I think I want to say thank you. Now, all these ideas did not come from my head, so I have some references. I've mentioned Emmanuel Kulu, who wrote I, Black Pharaoh, talking about a black pharaoh. In fact, the black pharaoh like Nafarka and all those people, and they ruled over that empire successfully. Paul Gergis did a whole lot of work on ethnomathematics, trying to, because the fact is that as far as a human being, you have an experience with your environment. So, and there are definitely things that emanate from that. So thank you so much for listening. Thank you for the opportunity once again, ARN.
Thank you so much, Doctor, for your presentation. But I would first highlight the questions that we have had from Yasquin, Shelby, Amos, and the rest. But just before I do that, a brief recap of Dr. Dansu's presentation. He had highlighted that what we seem to be experiencing right now is an African epistemological renaissance that tries to harken back to the roots of knowledge and culture and research that can be traced all the way back to ancient Egypt. And this sources can be said to be the origins of not only knowledge and philosophy and science in Africa, but in the whole world, because of the Greek connection. So we'll probe those ideas a little bit further, but thank you for your presentation. I was very fascinated when you said Ayo as a game can be examined for allegory, geometry, and fractals. I was like, I used to play such a game, as a child. I never knew I was dealing with allegory. So, yeah, thank you for your presentation. So first question from Yasmin. I think this question is directed at our first presenter, and it says, do either of the speakers have an example of a Western theory, philosophy, stroke idea that might have begun in Egypt or most Southern African regions? So I guess that question is like all these ideas we are exploring about Western science, can any of them be traced directly to African knowledge forms? It's one of the questions. I'm going to ask the second one from Shelby. He says, can we speak the significance of how we can call science and religion intertwined in Egyptian and other African worldviews?
Sorry, Uti, can we take it one after the other?
Okay. They seem to be related. That's why I wanted to ask both of them. Okay. So essentially what they're asking is, are there specific ideas of Western science that you presenters can point to as having direct African connections? And then the second person is wondering about the role of religion in conceptualizing African scientific knowledge.
Yes.
So both presenters, feel free to engage.
I can try to answer the first one. So you you know, Africa has to wake up to start singing their praises, right? Just think of someone, coming, I think, coming to Onitsha to discover River Niger, where people have been going to River Niger to fetch water, to cook, to take their bath, to do their day-to-day activities. And then somebody called Mungo Park came at some point and discovered River Niger. So it's because, our people did not project that we had River Niger, okay? That's why someone had the guts to come in our backyard to say that he discovered it. So I think we should start documenting ideas. It doesn't matter how small it is. Just document it and push it out there. Anything written down is preserved for posterity. So that's what I think there. I think that it's possible that there is a whole lot of philosophy that originated from Africa, but the West will attribute it to themselves as soon as they pick it up. Okay, so that's the point I want to make on that. I'm not aware of any clear philosophy that they attribute to Africa, but I know that a lot of them must have started in Africa, and we are baptized at some point. In terms of religion, personally, I would like to separate religion from science, because religion has to do with faith, okay, but science, to me, has a lot to do with empiricism. So you have to have an idea, then you test your idea, okay. If the result from the test agrees with the initial idea, even if it fails, you can go back to say, okay, this idea I had before, I can modify it, to agree with the result. So one thing about science is, it has to undergo tests. Anything you cannot test, is not science. Yeah.
Thank you for that very succinct response. Yeah, it's very important that we remember the role of the graphology and writing in the preservation or non-preservation of African knowledges, because I have come to understand that the role of the oral tradition in transmission of knowledge has been one of the disadvantages that African knowledge forms have had, because it's a popular expression that when an old man dies, a whole library is burnt down. So the fact that early ancient African traditions, some of them didn't have writing systems which knowledge could be coded and transmitted from generation to generation, that's an important point that you raised in the process. Yes, so there are other questions that have also been asked. I think this question is, but before we go to that, Dr. Dansu, I don't know, would you want to jump in with this issue of one, relating African knowledge, contemporary European science to
Yes.
African knowledges, and on the other hand, religion as an important index in understanding African epistemology?
Yes, first of all, I agree with the fact that oral tradition that has characterized the transmission of knowledge in Africa has done more of disservice, because in fact, if you remember, like if you had a very good relationship with your grandparents, or for instance, I still met my great grandmother. Now, sitting with them alone, there's a lot of things they talk about, but those things probably are not in any document anywhere. And then they die, and those things go with them. Even if I think somebody said that the faintest ink is better than the sharpest memory. I think one of the biggest undoing of the African scientific perspective is the fact that those things are mostly transmitted through oral tradition. Looking at medicine, for instance, there's a lot of things that people had access to, but those things were never documented, or probably when the colonial masters came, or when the slave traders came, or something, probably they made us feel some of those things were they were fetish or something. But plants, whatever, if you're using any pharmaceutical stuff today, those things are basically from plants, right? So which is better, the original thing or the refined one? But of course, there's no point crying over spilled milk. That's why we are here. That's why we want to chart a course for the future. Now, talking about direct philosophies. Now, if you look at Greek mythology, you can easily trace most of those things back to Africa. Of course, well, I am, I'm very cautious to make this kind of statements, right? But, for instance, we all know about Thor, right? I think Thor is one of those Egyptian ideas. But if you come back to Africa, then you see people like Shango in the Yoruba mythology, for instance, and the idea is about the same. The only thing is that maybe they've now been able to package there, and then everybody is looking forward to watching all those movies. Now, just look at them and think about Africa. You find a correspondence. So it's either they learned from Africa, or everybody, or nobody's more knowledgeable than anybody, because we have our experiences, and all of these things tend to converge. And that takes me to the last point. In my own case, I would rather not think that there should be a split between religion and science. Because, for instance, if you look at my presentation, I kept talking about people who are both philosophers and mathematicians, and even more. You can find a philosopher who is a mathematician who is also an architect. Now, all of those things tend to balance themselves out. Now, science is based on facts that are verifiable and things like that, But the thing is, the part religion plays in that is that there are some things. Okay, it's just like there's this usual comparison between a man and a woman. There's this thing we say that women are intuitive. For instance, my wife can just come and she tells me, "Let's do this thing," and I'm like, "No, it doesn't make sense to me." But then, so I'll wait it. She'll wait it out. I'll do something against what she said, and I'll make a mistake. Then I'll come back to her point. Then my mistake, my trial and error will lead me there. So she has that intuition. And then for me, I'm looking for logic. Now, for me, I see religion as to many people, it doesn't look logical, right? But it's like, for the most part, religion is there waiting for science to catch up.
Yeah.
I think I want to stop on that note.
Excellent. Yeah, thank you so much. There's a lot of interesting conversation happening in the chat, and I think one of the points raised by Brother Shabazz, and I think he has a slight pushback, which will be interesting in generating further conversation. So, Brother Shabazz, if you're there, you can unmute yourself and ask your question or make your comment.
Africans contributed to science, but those contributions did not exclude the sacred from scientific knowledge. So if we're going to talk about ancient Egypt, we have to deal with the fact that the ancient Egyptians contributed lots to scientific knowledge, but they did not separate scientific. In fact, their scientific knowledge was informed by their understanding of the sacred. I think part of the problem is maybe that we really don't understand. We don't have a good grasp of what the sacred is. The sacred, just one basic understanding of it is simply is that an understanding that humans are in the world and that there are forces beyond. I'm sorry, my daughter's grabbing my leg. There are forces. There are forces beyond human control that control the universe, and that we have to find a way to be in balance with those forces. And our religion, or the best traditions of our religion, I think, are really about understanding those forces that we call protons, electrons, neutrons, gravity, all that was being understood, but from a different angle. Europeans decided that you could only do that through separating the religion because they didn't understand what the religion was. But Africans obviously understood science as fundamentally sacred. And so I don't understand why. In fact, I would add more. I would say too that even if you look at quantum mechanics, quantum mechanics is making observations now that our ancients understood thousands of years ago. For example, this idea that that when you create subatomic particles together and then separate them over over vast distances, they still behave as if they're connected, right? Africa's understood these connections long. That the idea that we're all connected somehow is Ubuntu, and that when you do one thing here, something happens there. These are African ideas. So my basic, I don't want to ramble, but the basic idea is that I think we're underestimating the degree to which science, or degree to which the sacred can help us to understand science or interpret science in a way that maybe Europeans can't fully grasp.
Yeah, excellent point. This makes me think about the general conclusion in many cycles that the efforts to understand African science, in isolation from religion, culture, sociology, often fails because there is this interconnectedness of all aspects of knowledge, where you would have an idea that is distinctly philosophical, and but you have it expressed in religious terms, and so on and so forth. And this brings me to a question that had been asked to Dr. Ezeribe. Someone is interested in knowing your idea of the neutrino, and wondering whether there are contemporary applications of that concept to technology. Are there advances in technology that are utilizing that aspect of research as, the material for such technological advances?
Right, thanks. So before the discovery of electrons, there was nothing like electricity, right? So before then, you cannot build cars. Before we found electrons, you cannot run anything. You can't run the computers. You can't do anything. But now we have these neutrinos. We are trying to understand what they really are. We've discovered them. We know they exist. We know some basic, ways that they behave, but we need the in-depth understanding of their behavior before we can apply them. But using what we know as of today, we could say, we know that they're weakly interacting. So if I send a neutrino from here to China, maybe through the Earth, it's going to pass through the Earth without stopping, okay? Assuming I can encode some messages in the neutrino and send it to China, it's going to reach there faster compared to EM wave that is sent over the Earth, right? So yes, we can optimize neutrinos for telecommunication, if you like. There could be a lot of development coming out from there. Anything that needs, like in submarines, as of today, what they do is they have a surface station, then use cables to run from the surface station to under the water where the militaries are. So, but assuming you have like a neutrino gadget, communication gadget, you can send the messages underwater, without having to run cables and things like that. So yes, there are prospects, but before we get to that, we need to understand neutrino oscillations very well. The mass hierarchy problems, we need to resolve that. Know why, understand the mass ordering and so on. Yes, there are still problems to solve, but there is a lot of potentials because this is an abundant particles that we don't need to do anything to get. It's free. Billions of them are passing through your palm every second, whether you like it or not. Okay, so it's a free giving. As soon as we understand them, we start utilizing them.
That is really, really awe-inspiring. I'm never going to look at my palm the same way again. But yeah, there's a question. Thank you for that explanation. There's a question from Shelby. I don't know, Shelby, do you want to unmute and ask your question? Or has it been addressed already? If not, please feel free to unmute and ask your question. Shelby Ward.
Oh, hello. I think you addressed the question. So it was the question about the significance between the interconnectedness of science and religion and different African worldviews. So thank you so much.
Thank you. Thank you. And then your screen, I'm so sorry if I'm pronouncing your name wrongly, but yeah, do you want to mute and possibly ask your question? I think it might have been addressed, but I'm not certain. I want to give you the chance to do that. So please feel free to unmute and ask if you are there and can hear me. And then thereafter, after your screen, then we would have Winner come in to ask his comments. And then any other person who has questions related to the presentation, just feel free to indicate by lift of hand, type in the chat, whichever you prefer. So your screen, are you there?
Hello, do you hear me?
Yeah, hi.
Hello.
Yes.
Yeah, so I don't particularly have a question right now because I believe that the speakers have answered that partially. And so I mostly want to address both what Brother Shabazz said and some of the content of what the speaker said. And the idea I have is that we'd like to explore this idea, right? That some of the modern ideas we have, Western ideas, might have come from North Africa. And so one example, for instance, is how Shango, right, the Yoruba god, is translated into Thor and the other thunder gods. And so I'm going to use that example to describe what I mean. And that is that perhaps it's not because they come from Africa that they are the same, right? But that we are human, because no matter where you are around the world, right? Whether you are South American or African or Asian, you're bound to come across the same ideas, right? Like there are gods everywhere, there are beliefs everywhere, and we love to explore the universe. So basically, I'd like to point out how we should try to look for the difference between causality, as in there is a connection between Africa and the West in their ideas, right? Which is of course not impossible because there are, migration, etc. But there's also this other path, which is that it could be that they have independently come about. That's about it. Thank you.
All right. Thank you for your contribution. So there we have another insistence on tracing the link. And then, yes, well, there's also an interesting question in the chat by Biodun Afolabi, but just before we bring you on, Wina, you had a question or a comment, so feel free to speak.
Yes, thank you very much, Uti. I really enjoyed the submission of your screen there, which is for me another perspective to viewing this whole thing, in the sense that there could be this parallel occurrences to the realization of things that are happening by people in different races and even at different times, just because of the human capacity to find things out and to be able to explore, to investigate, and to come up with either an explanation to something or a solution for something, or a way to describe a phenomenon or certain phenomena. And so I really like that from your screen. Thank you very much for that submission. And I'm also just coming in to really appreciate the speakers and the topics that they've both presented, and Dr. Anthony's presentation, starting from the basics and from the whole where things have started from, matter and the fabrics of its component. And I don't really have a question. I'm just curious about the looking at the topic for today and the agenda for today and the theme of the presentation, which is the origin of the universe, or where the universe started from, and from an African perspective. And I'm really interested, and I'm thinking very particularly about the submission of both of our speakers. And Dr. Dansu Yeah, Dr. Emmanuel Dansu, his own presentation, which was talking about particularly talking about how education and ancient learning could be traced back to Africa and to Egyptian times, and talking about people like Pythagoras who had their tuition over there in Africa. And my thinking has gone to the angle of the fact that if we are thinking of say an African perspective to things, or an African perspective to how the universe has evolved, what I've sort of observed, or what I've come to take away from the submission of both is aligning with, which is quite good that Josquin spoke just before I spoke, aligning with what he sort of said, in the sense that perhaps, and also with the last slide of Dr. Emmanuel Dansu, perhaps there's no way to really say that these people had it from the beginning, or had some form of monopoly of the knowledge, or monopoly of the research, or the monopoly of the finding, but that there have been parallel discoveries, or parallel attempts at discovering these things without someone being the one who has found it.
The chat box, the presentations were very, very interesting and mind-blowing, especially from Dr. Ezeribe. So I was really fascinated with the idea of dark matter. Although this is not the first time that I will be hearing about dark matter. I think the last time I heard about it, it was said that everything that has been known in the world is at 3%. But now I'm hearing today that it has at least moved to 4.6%, which is an improvement. But my question is, when you talked about the idea of dark matter, does that idea include the fact that there are certain indigenous knowledge in Africa that are yet to be unraveled, that are yet to be known? And if that is true, I think the onus lies on us, contemporary African scholars, to find a way to unravel some of these knowledge systems. And in doing that, I think from the second speaker now, talking about the idea of rationality that has been bestowed to us by the Western world, we have to maybe undo ourselves from that idea to really unravel our own idea of indigenous knowledge. So how do you see Africans doing that? Do you have an idea of the indigenous rationality that we need to employ to unravel the dark matters connected to African indigenous knowledge systems? Thank you.
Thank you, Afolabi. I will, Brother Shabazz, I've seen your hand up for a while. Do you have a question that could also be asked, so the discussants would answer both simultaneously, along with Afolabi's question?
Yeah, a similar question. Can you hear me?
Yes.
Can you hear me? Yeah, a similar question about rationality. I've also noted in quantum mechanics that some of the theorists are saying, for example, that there is no objectivity, which pretty much upends, the Western approach to science. And so, what does that mean in terms of, African knowledge and new African knowledge? And the fact that I think a big part of the problem too is that, the trajectory of our knowledge in terms of scientific knowledge is very much a function of imperialism and exclusion and colonialism. And so you have a small clique of primarily or overwhelmingly Europeans who produce the knowledge, but that production requires the oppression of all this brilliance all over the world. There's so much, I'm in the United States, and I've been to West Africa many times, and you have all this knowledge and intelligence just locked up, and because they don't have the opportunity to shine. And I would submit that if that were to change, we might even have a whole new trajectory on what science looks like, and all these assumptions that we have about scientific knowledge might be profoundly changed.
Yeah, great points. Excellent. So the tails of all these questions is what can Africa contribute to the increase in knowing more about the universe, and what exactly would such contributions look like? Our presenters, can you respond, please?
Yes, I can say something. So look, the fact is Africa is not relegated. Okay. The point I'm trying to make is that knowledge is now global. Okay. Take, for instance, mobile phones. Okay. Africa should be able to pick mobile phones and either improve on it, okay, or make a resounding change. For you to do that, you need to understand every component in the mobile phone. So if we are trying to drive back, okay, to ancient knowledge, that's fantastic. Africa has done very well beginning, reading, writing. Writing started, I think, historians claim that writing started in either Egypt, Iraq, or China, one of these three. So Africa is top on the list. Okay, so Africa has been at the forefront of science, if you like. But what I'm trying to say is the science has moved beyond ideas. Okay, if you have idea, first put it down. The second thing that should follow is to think, maybe as a group, think of a way to test that idea. Coming back to religion, why I wanted to separate religion from science is because if you want to look at religion as an embodiment of the whole universe, fine. That universe has been explained in the Bible, close the Bible, and test everything in the Bible. That's what I'm saying. Test all the theories in the Bible. Why the Bible remains closed. Why the Bible has to be closed is it could introduce a bias. You should be able to reproduce results without, the Bible. So that's what I'm saying. I'm not saying that you shouldn't read the Bible, no. I am a Christian. I read my Bible. I know what my Bible says. But, if we must make progress, we have to start thinking of a way to affect the life around us. We have ideas, we put them down, we test them, make sure that the ideas are concrete, and then we think of a way of applying them. In terms of dark matter, is there African indigenous knowledge? I believe there will be millions of knowledge lying around Africa. Okay, but what is really important is the zeal to bring these ideas to test. If you have ideas and you don't test them, it can never be useful. You got to get the ideas, you got to have a drive to test them. It is the only thing that people will understand is result from a test. Okay, you had this idea, it has been tested, now it is proven to work. That is what people in the world understand. Anything apart from that is not going to sell. If you have an idea and put it down, fine, it's going to remain there. Somebody from Europe is going to take it up and test it and become the discoverer. He discovered that. Okay, but if Africa wants to make progress, we should change I think personally that we should change our thinking that we have ideas, we put them down, we work to test them ourselves. We shouldn't bring them to Europe. We should test them ourselves, get those results, and think of how to apply them. Why God created, if you're thinking of religion now, why God, or if you're a Muslim, Allah created the universe, is for us to use things that are in the universe to help ourselves. Okay, so we need to understand those things and then use them to help ourselves. Okay, having ideas is not enough.
Thank you. What would you say to this, to Dansu? How would you also react?
What was his question? Sir? All right, so Dansu, right? Okay, yes.
Yeah, Dr. Dansu, the question of African knowledges and the ways in which they can increase conceptions of the universe from the 4.5% to something much more. To what extent can they contribute?
Oh yeah, like I think I'll have to take off from where Dr. Ezeribe stopped, and that's very important. Jumpstarting development is very important now. We cannot afford to reinvent the wheel again, so we may have to jumpstart. I think that's the key word I want to say in this regard. And we see examples of that already. For instance, I think in one of our previous discussions, I mentioned this idea of banking in Nigeria, for instance, and it's quite heartwarming that we've been able to jumpstart many things in that regard. For instance, with a phone that is not internet enabled, you can do bank transactions. But maybe in some of these so-called advanced countries, they won't even think about that because it's not necessary. So and that brings up the idea of African solutions for African problems. So we have to look at our particular situations and give and provide solutions that are relevant in our context. Then that takes me to the idea of collaborations. Now, at this point, Africans are everywhere, like all over, like all the corners of the earth, we are there. So the collaborations are very important. The Africans at home and the Africans in diaspora, we need to come together like never before to ensure that we are able to give solutions that are relevant, direct to our problems. And lastly, I like to talk about documentation, like I said the other time. Just now, the idea of Tesla just came to my mind. Nikola Tesla lived several years ago. And today, probably based on his ideas and all that, many things are coming up, maybe like electric cars or whatever. You see, so there are probably some African ideas that were not documented. So we now have to go back to think those things up again. So right now that we are here, so all these ideas we're coming up with, I think we should document them. So people, even if you're not able to execute some of these things, people that come after us can have they can have materials to work with and to build on. So that way we can contribute a fair share of solutions to the world's problems.
Thank you very much. That has been very well responded to. I think lastly, we would have, there is a question from Janice, and we'll bring you in, and then we will hand over to Augustine for our concluding remarks. Janice, yes, you can ask your question.
Yes, thank you very much for the presentations and for the, I think it has been very illuminating. Our conversation has led us in many different directions. I don't know how many of you saw the comment that I put up before, but our conversation in a way is stuck between two important points. One is that as Africans, because of the experience of slavery and colonialism and imperialism, we always feel this need to point out that somehow we are rational, we are scientific without experience. And as much as we understand that, we also don't need to be limited by that. And by limited by that, I mean, we don't need to narrow our conversation about whether or not we are scientific, whether or not we had the idea first. The practice of science is such that it's a human faculty. It is not something that Europeans had or Asians have or Africans have. It is a human faculty. And with that, I think for me, coming from the perspective of the history of science and technology, I think it's important to also understand that many societies have different philosophies of science. And just the European and the American sort of type of science is the most dominant one, it doesn't mean that that's the only way to understand the world. And in fact, humanity we'll have a lot of trouble if we only depend on this one way of understanding science. And so I think some of these questions about, who had this idea first will be strengthened if we take the time to understand, okay, so what were these African philosophies of science still in practice today? So if you take an example of, like mobile money, people use it in particular ways, but you cannot just talk about mobile money thinking about the fintech Silicon Valley element. You also have to consider, there's a way Africans function and we take care of our families. And so if someone is in town and they're earning money, they have this responsibility to send that money back home. And so the way we use technology also captures this understanding of family relationships and responsibilities and all these things. And even before mobile money, there were other ways that we were using technology to meet these needs. So science and technology is about the agency that we have as human beings and us choosing particular ways to lead us to the ends that we want. So let's not be stuck in like who did this and who. Let's think as Africans, we've always been people who are scientific in many different ways, and we can continue to discover. And at the same time, people can also engage with science that comes from other places and learn how to use them in ways that are relevant to the questions that we're trying to answer now. It's not an either or, it's both. I will also encourage you to look into the work of Clapperton Mavunga, who I shared in the comments. He does a really good work about trying to help us understand science that is indigenous from Africa and science that is, coming into Africa. Even if science is coming into Africa, it is our science because we're using it. We're doing things with it that are African. No one else is doing things. And it doesn't work that way because of context. We have particular needs. So let's, think of something that humans can create and can use in particular ways, even though, of course, there are particular limitations that have to do with politics and the legacies of imperialism and things like this.
Thank you so much, Janice. That's a great synthesis of the conversation that have been happening so far. So yes, at this point, I will link in Augustine, who has some comments to make, and then
much. And thank you, Uti. Thank you, Winner, and special thanks to our speakers. I just want to make a quick clarification on the last speaker's remark, that the topic that has been handled today is by the experts from astrophysics and mathematics is not a reaction. It's not a kind of apologetics to actually defend the facts that we have science and technology in Africa. Rather, it is a kind of presentation that shows us where we can contribute to the global discussion and where we have contributed. And one of the things is like we talk about perspectives. When we want to bring forward a perspective, you have to look at where it started from, the root. And that is why you see how Dr. Anthony Ezeribe showed us the root in just even the day-to-day living, in day-to-day activities, in time, in games. The same thing with Dr. Emmanuel, in showing even the buildings and even in positioning, that these are just not activities like a spider making a web, but they without being conscious of what it's doing, but to show the rationality behind them. So I just want to actually make a short remarks on that. And at this point, as we appreciate our speakers so much, we just want to thank them. I want to give them time to give us their last words, their last remark based on all this. So I hand over to Dr. Anthony to give us his last word, his last remark to the conversations that are taking place. Dr. Anthony, please.
Yeah, many thanks to Uti, Augustine, and all the organizers. I'm delighted for the opportunity to speak to the African Research Network. It's a pleasure, and I would like to thank everyone that attended the meeting for the heartwarming questions, and I believe a productive discussion. I said thanks to all of you. To conclude, I will say that a lot of good things will come out of Africa. Yeah, there has been colonization, but Africa is still one. Thanks very much.
Thank you very much, Dr. Emmanuel. Oh, please go ahead.
Yes, I like to talk about the fact that as humans, we cannot afford to live in silos just because we're Africans, right? Like we cannot afford to say, okay, because we're Africans, it's anything. The only thing we're only bothered about African things because as humans we have a shared human experience. So whatever we can learn from anywhere, whatever people can learn from us, I think we should come to that sharing table where there's a cross fertilization of ideas, and in the long run we have a better place that we to live in for all of us humans. And I also want to say that ARN, keep at it. We are getting somewhere, and I'm particularly grateful that ARN is bridging the gap of documentation. Like we have all these things recorded, we have them transcribed, so people can have materials to interact with in the future. I think that's a very nice one. So keep at it. I'm always available in any way I can help.
Thank you so much. And we thank our participants for their presence at today's event. Next month, we're going to have the continuation of the conversation, but in another way. We're talking to people in computer science and NLP and data analysis. There have been questions with regards to the representations or the localizations of this technology. And it's not just like, it's not a talk to defend that there are technologies in Africa. And that's one of the things we begin to make the disclaimers. It's not to refer to the post-colonial era, but it's an attempt to look at how conversation moves forward from what is at stake. So the question that has been asked by this forthcoming webinar has to do with the natural language processing technology and the programming framework and the whole idea of mobile phones and other devices that are being produced used in Africa, but the localization becomes a problem. And these are things that people are working on in trying to develop those things. So the experts are going to come and they're going to talk about what they have done, how we can be able to implement that, and how some of all this indigenous framework can actually help in contributing to global discourse from our own part of the world. So we appreciate if you will find time to also attend, and we thank you so much for your participation today. On behalf of the team of African Researchers Network, we want to say have a great day and hope to see you another time. Thank you so much, Dr. Anthony. Thank you, Dr. Emmanuel, and thank you, our participants. Do have a great day. And Uti, thanks for your moderation and hosting. Have a great day. Bye.